Now we're going to go on to section 4.2, trig functions of acute angles. We are going to first look at all 6 trig functions. Up until now, you have probably only seen the first 3, and those are the 3 you work with in geometry. Your first one is your sine function. And we know that our sine is equal to the opposite side of your angle over the hypotenuse. Okay? The next one you've seen is the cosine function. And that is equal to the adjacent side of your angle over the hypotenuse. And then the tangent function would be your opposite side of your angle over the adjacent. Okay, now onto the 3 that you haven't seen. They are the reciprocals of these. Okay, so the first one is our cosecant. Okay, cosecant. And cosecant is the reciprocal of your sine function. It is equal to the hypotenuse over the opposite side. Okay, then we have the secant. And that would be the reciprocal of your cosine, the hypotenuse over your adjacent side. And then your cotangent function is the reciprocal of the tangent. And that would be your adjacent over your opposite. Okay? Those are the 6 that we are going to work with for this chapter. Okay, now we also need to talk about something else that you went over in geometry. And that is special right triangles. So the first one we're going to talk about is we're going to evaluate all the trig functions. So this is example 1. And we're going to evaluate trig functions for a 45-degree angle triangle. Okay, so in geometry, you talked about special right triangles. And one of the special right triangles that you discussed was when we have a right triangle and we have one of the angles is 45 degrees. Okay? If one of the angles is 45 degrees, then the other one is also 45. And so we know that the legs, the length of the legs, are congruent. So if I have this leg as 1, then this leg would also be 1. And then you could use the Pythagorean theorem to find the length of the hypotenuse. So it would be 1 squared plus 1 squared would equal your hypotenuse squared. So 1 squared is 1 squared is 1, so this is 2 is equal to the hypotenuse squared. So if I'm trying to find the length of the hypotenuse, it would be the square root of 2. And that works for all triangles that have for all right triangles that have a 45-degree angle. Okay, so now if I want to write my trig functions for this 45-degree angle triangle, my sine of a 45-degree angle is going to be opposite. So if I take one of my 45-degree angles, it doesn't matter which, the side opposite is 1. And the hypotenuse is the square root of 2. Okay? But we do not want a radical in our denominator. So we want to get that out of the denominator, so we're going to multiply top and bottom by the square root of 2. And 1 times the square root of 2 is the square root of 2. The square root of 2 times the square root of 2 is 2. So sine of a 45-degree angle is the square root of 2 over 2. Okay? Cosine of a 45-degree angle. Cosine is your adjacent over the hypotenuse. Now, if I look at this angle, my side adjacent is 1. So I'm going to have the same answer as my sine of 45 degrees. And if I rationalize the denominator, I'm going to end up with the square root of 2 over 2. Okay? Tangent. Tangent of a 45 degree angle. My degree symbols in here. Tangent, remember, is opposite over adjacent. So my tangent of a 45 is 1 over 1, which is just 1. Okay, now let's talk about the other three we don't normally talk about. Cosecant. Remember, cosecant is the reciprocal of your sine. Okay, so cosecant would be your hypotenuse over your opposite side. So for cosecant, we would have the square root of 2, and double equal signs there, square root of 2, which is our hypotenuse, over 1. Or just square root of 2. Or if you actually calculate that out, it's 1.414. Okay? For our secant, SEC is the abbreviation for that. It's going to be the exact same thing. So square root of 2 over 1. Which is 1.414. Okay. For our tangent, the reciprocal of 1 is 1. Okay. Those are the special values that we will get for sine, cosine, tangent, cosecant, secant, and cotangent. Oops. This is a cotangent. COT is the abbreviation for cotangent. COT. Okay. Now, let's talk about the other special right triangle that you guys first learned in geometry. And that was when we have a 30, 60, 90 triangle. So, example 2. Trig functions. Of 30-degree angles. Okay, so the trig functions of 30-degree angles. Let's draw our triangle first. When we have 30-degree angles of a right triangle, we know that our 30-degree angle is here. The side opposite is our shorter leg. And our 60-degree would be here. The side opposite that would be our long leg. And obviously the side opposite our right angle is our hypotenuse. Okay? In this type of triangle, we know that the 30-degree angle is half the length of the hypotenuse. So let's say our hypotenuse is 1. Our side opposite our 30-degree angle is 1/2. And if we do the Pythagorean theorem, we can find the third side, which is the square root of, well, let's just do it out. We have 1 squared would be equal to 1/2 squared plus our other side, we'll call it x squared. Okay, so 1 is equal to 1/2 squared, which would be 1 over 4 plus x squared. Okay, so if I subtract 1, subtract 1/4, would equal my x squared. 1 subtract 1/4, if I change this to 4/4, because 1 is the same thing as 4/4 minus 1/4, I would have 3/4 is equal to x squared. Okay, and then I have to square root that. And the square root of 3/4, we cannot square root 3, but we can square root 4. The square root of 4 is 2. So it would be the square root of 3 over 2 would be my other side, my x side. Okay? So I draw this out. In my 30, 60, 90 triangle, if my hypotenuse is 1, my 30-degree angle, side opposite, is 1/2, and my side opposite the 60-degree angle is the square root of 3/2.